students. Today we have Proposition 41, Book 1, Proposition 41. A parallelogram on the same base and in the same parallels with any triangle is necessarily double that triangle. Given parallelogram, triangle, on the same base and in the same parallels, that's given. Thus, it is required to show that this parallelogram is double this triangle, okay? Easy prop. We're just going to use, I forgot to draw this one here. We're going to use two propositions. Number one, from our bag of knowledge. Number one, that triangles on the same base and in the same parallels are equal to each other. We've shown that this black triangle would be equal to this red triangle. And then the other thing is that in parallelograms, the diameter bisects the parallelogram. Okay, so let's start off by doing that. Let's bisect this parallelogram. Great. So here, with this blue triangle now, on this, comparing it to this red triangle, we see that they are on the same base, this triangle and this triangle are on the same base and in the same parallels. So therefore they are necessarily equal. We know that from our bag of knowledge. Okay? And we also know from our bag of knowledge that I showed you earlier. So anyway, this is equal to this. But this is half of this. We know that the parallelogram is, the diameter bisects the parallelogram. So this triangle is equal to this triangle, and the two things make up the whole of the parallelogram. So the whole of the parallelogram must be double one, okay? So if the two triangles are equal, the whole is double one of them. So this parallelogram is double this triangle. This parallelogram is double this triangle. But this triangle is equal to this triangle, okay? So if this is double this, and this is equal to this, the derivation of two things equal to the same thing, or equal to each other, that is to say this is equal to this, and this is half of this, this is also half of this, which is to say that this parallelogram is double this triangle. Thus we have shown that a parallelogram on the same base and in the same parallels with any triangle is necessarily double that triangle. Quod erat demonstrandum, which was to be demonstrated. Thank you so much. Bye-bye.